This is Henri Becquerel, a French physicist.
In the late winter of 1896, he stumbled upon a discovery that would reshape the world of science. He discovered radioactive decay. His magnificent discovery reshaped the world of science. Let's see the use of his discovery in today's world.
You and your professor are in the lab, studying and observing a radioactive element, uranium. That is uranium, a stable element but yet is very slowly decaying, as explained by the professor.
How is this rock slowly decaying?
To understand how it decays, we have to look at the formula first. Nt equals to the n naught e to the power of negative lambda t, where Nt refers to how much of the element is left after time passes, n naught is how much radioactive material we started with, lambda is the decay constant, and t refers to time. Let's take a look at an example question. Uranium-235 is a radioactive isotope used as nuclear fuel. It has a half-life of 704 million years. If a sample initially contains 80 grams, how much will remain after 2.1 billion years? First, we calculated the decay constant, which is lambda, by substituting the values from the text into the formula of ln 2 divided by half-life. Next, we substitute the values of initial mass of 80 grams and time of 2.1 billion years, which has been converted into 2,100 million years, into the formula above. Finally, after calculation, the amount of uranium-235 left is 10.12 grams. This graph shows how uranium-235 decays over time. It starts at 100%, and for every 704 million years, the amount halves, which basically means after one half-life, 50% of the substance is left, and after two, 25% is left, and the pattern keeps repeating continuously. By about 4 billion years, only less than 5% remains.
Oh, now I understand, Professor. But I'm curious, how can it be used in our society?
It is very useful in many situations, and to name a few,
radioactive decay is used in producing nuclear power. This is because heat can be produced during radioactive decay. The heat produced is then used to generate electricity. It is also very crucial in producing nuclear batteries that are often used in space exploration or remote operations, where switching batteries is very challenging or entirely out of the question. This is because nuclear batteries uses the natural decaying property of a radioactive substance to produce electricity. For example, the Mars Science Laboratory rover, which uses radioisotopic power systems that turns heat from radioactive decay into electricity through a thermoelectric generator.
It is also used in radiation therapy. The main purpose of radiation therapy is to kill abnormal tissue growth, such as cancer cells, by exposing them to high dosage of radiation.
So does that mean that all those real-world applications are what makes mathematics relevant today?
Yes, you are finally understanding it. Well done! While shopping, we would use mathematics to compare prices and calculate discounts to ensure we stay on budget. Not only that, mathematics is also applied in time management. We rely on math to manage time effectively, from planning daily tasks, setting reminders, or reading schedules in calendars. Mathematics is also applied when cooking because ingredients must be added in the correct amounts, which requires a good understanding of measurement units like dozens, milligrams, grams, and kilograms, which is needed to create a tasty dish.
Mathematics helps us solve the most significant problems of our time by giving us a language to explain advanced systems, the power to predict outcomes, and the methods to optimize solutions. Without mathematics, we wouldn't be able to overcome climate change, cure diseases, or even explore space.